Psilocybin may be best known for its ability to plunge the mind into kaleidoscopic introspection and lift depression with surprising speed, but a deeper and increasingly credible possibility is now taking shape. This humble compound from psychedelic mushrooms might be uniquely positioned to fight Alzheimer's disease from two distinct biological fronts. One targets the emotional devastation of early-stage cognitive decline. The other aims at the cellular and inflammatory chaos driving the disease itself. Taken together, these dual effects make psilocybin a molecule that deserves far more than a passing glance in the search for Alzheimer's therapies. Let's start with what we already know. Psilocybin's antidepressant power is unusually robust. In clinical trials, a single moderate dose has lifted treatment-resistant depression in patients who hadn't responded to years of standard pharmaceuticals. That matters enormously for Alzheimer's because depression isn't just a common comorbidity, it's also a predictor of future cognitive decline. Older adults with major depression have significantly higher risk of developing dementia. And for those already showing signs of memory loss, depression compounds a functional and emotional toll, often leading to earlier institutionalization, worse quality of life, and faster cognitive decline. Psilocybin could help break this feedback loop, restoring a sense of purpose, reducing anxiety, and quieting the existential dread that often shadows early Alzheimer's. But the real magic might happen deeper in the brain. Recent animal and cellular studies suggest psilocybin may promote neurogenesis, the birth of new neurons, and enhance synaptic plasticity, especially in the hippocampus, a region devastated in Alzheimer's. The compound appears to stimulate dendritic growth, enhance synaptic density, and foster connections between neurons in ways that support memory and learning. While the adult human brain isn't exactly a neural nursery, these structural changes suggest psilocybin might help preserve or restore cognitive capacity, especially when introduced early in disease progression. But even more intriguing is the growing evidence that psilocybin can calm neuroinflammation, a key driver of Alzheimer's pathology. In aging brains, and especially in Alzheimer's, immune cells called microglia become hyperactive, flooding the brain with inflammatory signals that damage neurons and accelerate the spread of tau and beta-amyloid pathology. Psilocybin, through its action on the 5-HT2A serotonin receptor, appears to downregulate this inflammatory overreaction. It doesn't shut down immune activity completely. Instead, it helps recalibrate it, reducing the chronic, low-grade fire that slowly cooks the aging brain. And here's where things get especially fascinating. Psilocybin may also improve mitochondrial function, another weak link in the Alzheimer's puzzle. Neurons in the aging brain often struggle with energy production, leaving them vulnerable to oxidative stress and degeneration. Preliminary studies suggest that psilocybin can improve mitochondrial dynamics, enhance ADP production, and reduce oxidative damage in neural tissues, all of which support healthier aging and may slow the progression of neurodegeneration. This constellation of effects, antidepressant, anti-inflammatory, neuroplastic, and metabolic, makes psilocybin remarkably well-suited to the complexity of Alzheimer's. It's not a one-pathway hammer trying to hit a single nail. It's more like a cellular conductor, fine-tuning multiple systems at once, lifting mood, calming inflammation, repairing connections, and improving energy efficiency. It's the kind of system-wide approach that matches the multifactorial nature of Alzheimer's disease. Of course, we're still at the early stages of this research. Most of the data comes from animal models or in vitro studies, and while human clinical trials on depression are robust, studies focused specifically on Alzheimer's are just beginning. There are important questions around dosing, frequency, and safety, especially in populations with cognitive impairment who may be more vulnerable to disorientation or anxiety from even low-dose psychedelics. But efforts are underway. Several biotech companies and academic institutions are designing non-hallucinogenic analogs of psilocybin that retain its anti-inflammatory and neuroplastic effects without triggering intense subjective experiences, ideal for older patients. The bottom line is this: psilocybin isn't just an emotional lifeline for people suffering from depression. It may also be a biological toolkit for restoring balance in aging brains. It offers the rare possibility of treating both the mood symptoms and the root pathology of Alzheimer's at the same time. Not by targeting one protein or one receptor in isolation, but by nudging the entire neural ecosystem toward a more youthful, resilient state. So, could mushrooms fight Alzheimer's from two fronts? The answer is They already might be, and we're only just starting to understand how far their reach could go.